to start this problem, the first thing we're going to do is we're going to factor it. And when we factor it here, we're going to get 12 is 2 times 2 times 3, and 18 is 2 times 3 times 3. We look for the common factors, which are 2 and 3. So what's the GCF going to be? At least the number part of it. It's going to be 6. And then looking at the variables, we have m's and n's. How many m's are going to be in my GCF?
So, 1.
Just one? Yeah, so we have 1 m here, and we have 2 m's here. So they only have 1 m in common, so there's just going to be 1 m there. How many n's do they have in common? There's 2 n's here, and there's 2 n's here, so how many do they have in common? 2, right? So our GCF is going to be 6mn squared. So now I'm going to draw my rectangles. I need to have how many rectangles here?
2.
Why 2 rectangles? Why 2 rectangles? Why not 3 or 4 or 7 or 12?
It's only 2 now.
There's 2 terms, right? So since there's 2 terms, we're going to have 2 rectangles. And we're going to fill in our rectangles. We've got our GCF out front. What goes inside of the first rectangle? 12mn squared. And, no, it's not the same thing. What goes in our second one? What goes in the second one?
18.
Just 18, that's it?
N squared and N squared.
Okay, so 18m squared, n squared. We're still missing something.
Negative.
It's got to be negative. All right, so now to get each of the areas, we're going to take 6m n squared times something and 6m n squared times something. What do we multiply by 6 to get 12? 2. Do we need any more m's? Courtney? Do we need any more n's? No, so it's just going to be... So it's just going to be what? Just 2. Okay, over here, what do I multiply by 6 to get negative 18? Negative 3. Do I need any more m's? So I have 1 here, but I need to have 2.
1.
So I need 1 more. Do I need any more n's? No. So now I can put the lengths in here. What's the length of this rectangle going to be? This one right here? 2. What's the length of this one going to be? Negative 3m. And so then when I write my answer, what goes out front? What goes out front? 6mn squared. And then in parentheses, what are we going to have? 2 minus 3m. So in number 3, the first thing we would normally do is do a factor tree. Can we do a factor tree on 5? No, because it's prime, right? Can I do a factor tree on, well, what number do we have here? It's just going to be a 1, right? Can I do a factor tree on a 1? I mean, isn't that 1 times 1? So can I just make a bunch of 1s here? So it's 1 times 1 times 1 times 1, right? We don't need to do all that. So there's really no point in doing a factor tree. What factor do they have in common? What factor do 5 and 1 have in common? Just 1, right? So our GCF here is going to be 1. And then we got to look at the variables. How about n's? How many n's am I going to have in common here?
1.
Just 1. Instead of saying 1n, I'm just going to put it as an n, right? You don't have to have the 1 in front. It's okay if you do, but you don't need it. So when I draw my rectangle, how many boxes should I have?
I'm guessing 1.
No.
2.
2, because there's 2 terms, right? What's going to go out front?
5.
Just E.
Yeah, 1n, or just n. And in the first rectangle, what am I going to have for the area? 5n. That's going to be our area. How about the second one? Negative n squared. Okay, good. So for each one, we're going to take n times something to get the area. What do I multiply by n to get 5n? 5. What do I multiply by n to get negative n squared? Negative n. Good. Okay, so we need the negative here to make it negative. We need the n to make it n times n, which is n squared. So then on the outside here, what do I have there? 5. And how about here? Negative n. I think Larry's got it. So what's our answer going to be?
N parentheses 5 minus n.
Good.
I'm glad you did this with us, 'cause, I would never know there was n. I would never know.
Does that make sense? Okay. How about number 5? This one's actually really similar to number 1, but because you can do number 6. So on this one, again, the first thing we'll do is a factor tree. So we're going to have 2 times 3, and then we'll have 3 times 5. So then we're going to have 6 equals 2 times 3, 15 equals 3 times 5. And what do they have in common? The 3. So the GCF is not 9, because there's only 1 3 in both of them, not 2. So we don't have to multiply those together, so it's just going to be 3. And then what are we going to do with the variables? Do I need any m's? Do they have any m's in common? Yep, they have 1. How about n's? No. This one has an n, but this one does not. So our GCF is going to be 3m. Now we need to draw our picture. How many rectangles am I going to have? 2 again, because there's 2 terms. And out in front, I'm going to have my GCF, which is 3m. In the first rectangle, what's the area? 6mn. And how about the second rectangle? 15m squared. Alright, so now we're going to take the GCF here and we're going to multiply it by something to get each of those areas. So we're going to have 3m times something here and 3m times something here. What do we multiply by 3m? Well, what do we multiply by 3 to get 6? 2. Alright, and what do we multiply by m to get mn? I've already got the m, so what do I need in here? I need the n. Okay, and then what do I multiply by 3 to get 15? 5. And what do I multiply by m to get m squared? How many m's are here? How many do I need? So how many more should I put on here? 1 more. So we have 2n and 5m. So what's the answer going to be? 3m times, what'd you say, Kira? Perfect. Now let me ask you this. Are these in the right order? If we wanted to put them in alphabetical order, they are not in the correct order. I'm not going to make you worry about that when we're doing these. If we're factoring something, you can just leave it in the same order as the problem was written. So you don't have to worry about putting them in alphabetical order. So even though M comes before N in the alphabet, this is the order that they were in when we got the problem, so we're going to leave them in that order. Let me ask you this question real quick before we do one last one, and then I'll give you the rest of the hour. What would happen if I distribute this? If I do 3m times 2n, what do I get?
6m.
6mn. What do I get when I do 3m times 5m?
15m squared.
15m squared. So if I distribute it, I get back to where I started, right? So that's exactly what we're doing here. We're doing the opposite of the distributive property. Okay, last one. We're going to do number 9 last. Factor trees. 2 times 6, 2 times 3,
What number you
2 times 10, 5 times 2. Ooh, gonna be a lot of 2's here. 8 times 4, 4 times 2, 2 times 2, and 2 times 2. We're going to have 12 equals 2 times 2 times 3. 20 equals 2 times 2 times 5. And 32 equals 2 times 2 times 2 times 2 times 2. So what do they have in common? No, not that many. How many 2's do they have in common? Yeah, they each have 2 2's. So the GCF is what?
6. I mean 2.
How about 4? 2 times 2? Yeah? And then how about variables? Do they have any A's in common?
Yes. No.
Do they have any B's in common?
No.
Do they have any C's in common? Do they have any X's in common? Yeah, they all have an X, right? So we'll put an X there in our GCF. So now let's draw our picture. When we make our rectangle here, how many rectangles do we need?
3.
Why 3?
This is 3 numbers.
Yeah, there's 3 terms, right? So this time we need 3 rectangles. And our GCF is going to go out front. That's going to be our 4x. What's the area of the first rectangle going to be? 12ax. How about the second one? 20bx. And how about the last one? 32cx. All right, and in each one we're going to take our GCF 4x times something to get the area. What do I multiply by 4 to get 12? 3. What else do I need? Ooh, it's not it. I need the A, right? So I've got the X in here already, but I need the A also. So I need 3A. What do I multiply by 4? Sorry, 4 to get 20. 5, and then we need the B in there. We already have the X, but we need the B. What do I multiply by 4 to get 32? 8, and then I need the C because there's no C in here yet, so we're going to have the C. So the widths of the rectangles are going to be 3A, 5B, and 8C. So who can write the answer for me? Or tell me what to write? Go ahead, Claire.